Hello everybody, this is Cameron Snow with Danomics.com. In this video I'm going to be reviewing how we can use additional inputs within the Mineral Inversion module, and specifically how we can use those to try and get a better solution on the water saturation. And the way we're going to do this is we are going to actually do an iteration where we're going to do our interpretation. We're going to run a flow, and then we're going to come back and we're going to do an iteration loop here. So let's get started. So here I have a project open, and this is a project that I've just done a standard interpretation on. I have gone through and I have worked through my various modules. I've worked through everything all the way through the saturation and the cutoffs. But I want to start with the inversion. So we can see here with the inversion, right now I've got my standard mineral mix turned on, and actually let me go to my default zone here. So you can see I've got my standard mineral mix. I've calibrated some of my parameters. I have included conductivity here. And what you'll notice is that we've got a really poor response in general on the saturation. It's coming in here where we have very little water and very high oil saturations, which would imply that our fluid density is most likely going to be wrong, and that would create a little bit of a misfit with our total porosity that's coming out of the inversion. So I would like to address that by iterating and putting some more controls on the water saturation. The reason this happens is because there's just not a lot of separation between the properties for water and oil on most of these tools. They're very close to each other in density and neutron response, sonic response, so it's quite difficult to get a control on this, and so that's why we need to go through and iterate. So once I've done this interpretation, I then go to my porosity interpretation module, and I choose the min solver porosity as my default here. And the reason I'm choosing that one is this one takes the grain density out of the mineral solver, but it doesn't take the fluid density out, and I'm actually going to use a row fluid value of 1 here. And I set my clay porosity, and then I go on to my water saturation. And here I've chosen to use an Archie total porosity method for this. I've gone through, I have, let's look at our Pickett plot. We've gone through, we've calibrated this. I'm fairly happy with how this saturation looks. So I've done that interpretation, and we can save that. So let's go File, Save. And then we come over here, and we're going to make a flow. And to make a flow, you can right-click and say New Flow. I've already made one. And within this flow, you'll add some log tools here. These log tools start with a log input, and you just choose the well database that you want to work with. Then we'll go to a CPI log calc block. And with this, a few things we need to do. First, we need to just set our CPI information. And so here, the file that I did my initial work with was called MEMV iteration test. Then I select the associated tops, well headers, and log database. And what that is doing is it's pulling my interpretations into the flow. And then I'm going to set up some user equations here. And we need to be careful of name collision. Of course, we already interpret a bulk volume of water here, but I'm going to set up some custom equations here, so I'm getting a name out that I know is unique. And I'm setting up two equations. The first is my bulk volume water total, and I'm labeling that with an underscore init because this is my first run through. And I'm setting that equal to my total porosity times my saturation. And then I'm setting a bulk volume hydrocarbon underscore init, and I'm setting that equal to my total porosity times 1 minus my water saturation. The reason we are calculating the bulk volume is, remember that the mineral inversion works in volume space. So instead of working directly with the saturation as an input, we need to work with a bulk volume. And then we'll add a log output tool here, and you just give this a name, and I'm just calling it mimv test export.ldb. And then all you'll do is you'll hit the play button on this flow. That will pop open the jobs menu, and then you'll be able to come in and inspect the job log and see that that is ran. So I've already ran this, and we can see that I've got this mimv test export.ldb. And so now you've got two choices. You can either come back and you can work directly on your initial project, or you can make a copy. For this, I'm actually going to make a copy, so I have that original. I'm going to say File, Make a Copy, and I'm going to call this mimv iteration 2. Oh, sorry, I accidentally clicked on the wrong file there. Let's make a copy of this one, mimv iteration 2.cpi, and we hit OK. And we'll click on our key well here, and we'll see that we've got our full interpretation here available to us. Now what we want to do is we actually want to go back to our mineral inversion. So this is where we wanted to do a round of iterations, and there's two things we got to do here. So first thing we need to do is we need to select the log database that we just created, because this the new log database will have those bulk volume hydrocarbon and bulk volume waters that we made. So we're going to grab that mineral inversion test export that we just made. Okay, so now that we've done that, those new curves are available to us. And I'm going to expand this out so we can get it all on one line here. And I'm going to say Edit Matrix. And I'm going to add two curves here. And when you first do this, it'll give you some errors because it doesn't know what these new curves are, but that's fine. I'm also going to briefly turn on our dolomite and our pyrite. And now what we need to do is we need to type in those new curves. So it's bulk volume BVWT underscore INIT, and we'll need to click create here. And we're going to fit, and we need to give that an uncertainty. And then down here, we're going to say bulk volume hydrocarbon init, click create, and once again, we'll put in an uncertainty weighting on that. And then we need to populate the properties for this. Now, the bulk volume water, that corresponds to just water. So it should be a 1 for water, and then it should be a 0 for everything else. And the bulk volume hydrocarbon corresponds to our hydrocarbon phase. So once again, we will enter zeros in for everything except for our hydrocarbon phase in this case. And now when we come over here and look at this, we now see that we have a different response. I'm going to once again, remember, I'm going to turn off the dolomite and the pyrite. I just briefly turned those on so I could populate the properties there. And I'm going to say done editing on the matrix for now. And now when we come through here and we look at these zones, we can see a much more reasonable response for our bulk volume hydrocarbon and for our implied hydrocarbon and water saturations. Now, if we want to honor those initial calculations that we made, we can of course come in and we can be a bit more stringent with the confidence interval on those, and you can see we're getting probably a much more realistic saturation response down here in the zones where we had calculated that. And let's hide that out of the way. And we may at this point actually want to come in and disable the conductivity. We don't really need that anymore because we were just using that initially to try and guide our saturation response. Okay, and so now we have iterated through this, and now what we would probably do is come down to porosity now, and whereas we were using the min-solver porosity, now we can use that min-solver porosity strict. This is the one that uses the implied fluid density from the mineral inversion, or essentially a sum of the fluids there. So we can choose that. And we'll see it makes a slight difference here. And then of course we can go to our saturation. We can update our saturation as needed, and then we can go to our cutoffs and continue our interpretation as we needed to. So that is the process for iterating through the mineral inversion and using a kind of an initialized water saturation. So just to summarize that again, what you'll do is you'll start with your standard interpretation. You will use in your initial interpretation, you'll do this interpretation, and you will not use your bulk volume water or any saturation components here in the matrix. You'll do that interpretation per usual. Then you'll come in and you'll run a flow that'll start with your log input. You'll then pull in the information from your CPI and the relevant databases, and you'll add the equations for bulk volume water and bulk volume hydrocarbons, and we'll make sure to give those a unique name so we don't have to worry about curve name collisions. Then we'll create that new CPI. We'll come back to our mineral inversion interpretation, and we will add the bulk volume water total, bulk volume water hydrocarbon, adjust the uncertainties on that, and then we'll need to make sure to go through and in our porosity interpretation use the strict version for the min-solver porosity. And then that is probably giving you about the most sophisticated approach for evaluating the effects of the fluid saturation within the mineral solver. I hope that was useful. If you have any questions, you can feel free to reach out to us at csnow@danomics.com. Thank you.